So I'm just going to give a brief overview of LayoutNG, where it's at the moment, basically, and shipping the first big bit, as I like to call it. If you've got any questions along the way, just shout them out or raise your hand. Hooray, thank you, Rob. I only just created these slides this morning, so it's going to be super unpolished. It is what it is, and it's not going to be my usual interactive talk, unfortunately. But onwards. Firstly, a lot of this wouldn't have been possible without with Emil, who left us last month, unfortunately. So pour one out for Emil, or don't pour it out, but consume some champagne for Emil next time you're drinking champagne. He had a huge impact on the team, and this whole effort couldn't have been possible without him. So onto the team. So the number of people working on LayoutNG has sort of varied over the years. This is, I believe, all the people that have contributed to it, including past team members, which are in asterisks. So Xiaosheng now works on style, for example. I may have missed a few people. I apologize, but this was me quickly going, crap, I need slides for this morning. So the sort of broad strokes of why we sort of embarked on this fairly large re-architecture was that it was becoming increasingly difficult to add features to the layout engine in a scalable way. And so to give an example of that, there were things like CSS regions, or even just basic fragmentation like multicol, which are incredibly hard to bolt onto our engine. And so CSS regions got ripped out. It's also been ripped out of WebKit, I believe, as well. And sort of, the engine is, the layout engine in particular is an incredibly old code base and has sort of had many owners over the years. So, you can see copyright headers from, 1997 type of thing. Initially, you'll trace back and get blame going, why is this line the way it is? And you'll reach like the initial KHTML commit. And because it's some of the oldest, classes in Blink, everything talks to it. So it's an incredibly piece of rigid code that was very difficult to move forward. We also believe that there was some pretty big performance opportunities going for this re-architecture, and we also saw it to fix a large classes of bugs. Layout traditionally has had some of the highest bugs within Blink. So I think at the moment there's about 950 open bugs in the Blink layout component. And this is, and if you think about, I'm sure, a lot of you, if you've worked in Blink for some time, you've gone through the process of, okay, I'm going to fix this bug. You try and create a patch for it. You create a patch, you submit it, and then you find out, at a minimum 6 weeks later that you need to roll it back and do some different approach because you've regressed some website. This takes an incredibly long time to do at scale. If you, multiply that, 6 to 9 weeks, 9 weeks on average by 950, you end up at, a lot of years, or a lot of, software engineering years. And that fundamentally doesn't scale. What we found, though, is doing large switches is actually cheaper because you only pay that web compatibility cost maybe once or twice over the period of a quarter. And that's sort of a far more scalable way of doing it. Questions? No questions? Nothing? All right. Excellent. If you embark on an architecture project like this, one thing that I would recommend is that you think about what principles that you're going to need to adhere to when you make decisions. So what do I mean by that? So when you during every day, you're going to have to make tens of decisions about how to structure your code. And software is a tapestry. You can have 1,000 different ways of doing something. You can choose to have something mutable that you mutate. You can tree walk all the way around. And if you don't have these sort of like guiding principles of how you're going to structure your decision making, you end up with a red hot mess very, very quickly. So going into LayoutNG, these were fundamentally our principles, is that we knew that we wanted immutable input and output data structures. If you've looked at our code at all, this has manifested in the constraint space object, which is all the information a parent layout gives to a child layout. We have immutable output data structures, which is the layout result, which is everything that a child wants to pass up to the parent. And we also have the physical fragment, which is effectively the output of layout. We also knew that going into this, that we wanted to stay away from, so if you've ever worked in the layout code base, you know that there is inheritance everywhere. The inheritance hierarchies are really, really deep, and they're super complicated to wrap your head around. So you might, I think, probably the longest inheritance chain is probably 7 to 8 classes long. And at each point, something is overriding someone else's function. This is incredibly difficult to wrap your head around. So that we knew, from the get-go that, we didn't want that. And so we're very anti inheritance for that reason. Data inheritance is okay, but we prefer composition for any code inheritance. We also knew that there was potential, we also knew that we wanted to sort of make sure that we allowed for, multi-threading at some point. And we also knew that, the amount of tree walking that we were doing in the old code base was costing a lot of time. So we basically, decided to force them to ourselves as well, that we wanted to minimal or zero tree walking. So practically, what does this mean? There's a lot of information that you need during layout that comes from either some arbitrary parent up the tree or some child way down below the tree. So instead of, when you need that information, walking all the way up the tree, that parent will propagate that information down. And that's effectively what that means. Questions? No one fundamentally disagrees with me? No? Excellent. All of Blink should be written this way. The other piece of advice I would give to you if you went down this re-architecture path is create a bucket load of types. Types are good. If you've ever worked in the old code base, you know that we've got probably not as many types as we should have. So there, for example, there's an object called LayoutRect, which is used for positioning, size. It's used for everything, and you never know which writing mode it's in. So we created basically a bucket load of types, and each of these you can convert between all of the offset types, you can convert between all of the static position types, for example. And so to give you an idea of what this looks like, this is some old code, which is trying to adjust to location. It needs to take into, LTR manually is vertical. There's a if you don't get the plus and minus here, correct, that's obviously a bad thing. Here's some more. Fundamentally, I think this is just, unioning a rectangle or moving it. But there is, there's a lot of code here. And fundamentally, it's not doing anything that tricky. In NG, this is basically what it looks like, is that, given a logical offset, you can convert it to another type, say physical, give the writing mode direction, the outer size and the inner size. This is converting a point, so that's why the inner size is empty. And, you can reduce, that crazy amount of code. It also means that, if you've got these types, you can't accidentally assign a logical coordinate space offset into a physical offset, which the old code base did all of the time. So it's sort of like, this is basically my therapy session going, I have feelings about software engineering. This is what I think.
It's just a caveat to that, Ian.
Yes.
Name your types really well, spend a lot of time figuring out what the name should be, and document them really well.
Yes.
I hate code bases with classes that make no sense.
Yes, I agree. This is now a group therapy session. This is great. The other thing I'd recommend is have a graph. Koji created this, I think, pretty early on, right? And this is super motivating. It is crazy how motivating this is. So this is basically like the start of 2018 through to, roughly, we were basically code complete, bug complete, probably around start of January. having a graph like this and going, checking back, oh, last month we're at 10,000 failures, now we're only at a measly 8,000 failures. That is incredibly motivating. It obviously, goes on a slope downwards. But even when you get to 1,000, you can go, oh, last month we're at 1,500. It's incredibly motivating. So have a graph. Graphs are awesome. So that's the development story of LayoutNG. Again, not much preparation. Any questions? No? Great. On to what happened. So we fixed a lot of bugs. We just, by flipping LayoutNG on, we sort of, as bugs were coming in for the old engine, and as bugs were being marked for retriage, we basically checked if they were fixed in LayoutNG or not. And this accounted for about 15% of all bugs in our layout component. And we basically just got to mass close, 150 bugs about at the M76 milestone. We have much better support for complex scripts. So this is an example where we can't, there's a span wrapping this lip here, for example, and we couldn't shape between them. Now we can. So we have got much better support for complex scripts. And the performance is also really awesome for them as well. We also passed a lot of additional WPT tests, yes.
I was going to say, how did you make sure you didn't regress the fixed in LayoutNG bugs?
We didn't.
Okay.
Yeah, we just mass closed them all. We were marking them, labeling them roughly when we were feature complete, and sort of if we go back to this graph here, sort of like we were done basically end of January. A lot of these were marking sort of around this time period, so we're pretty sure that this is something fundamental that we had fixed. And sort of this time period between like the first half of 2019 was primarily performance work, which also turned out to be incredibly easy, relatively speaking, because Koji might have different feelings about that. For me, it was great. I had like two immutable inputs, and I was trying to work out if I could reuse the output. It was great fun. Yeah, we also fixed a bunch of WPT tests that were up there. So I think this was mainly to do with writing modes. I think that mainly fell out just because we had those strongly typed objects now in our code base, and because of the great work that Emil and Koji did. A lot of inline fixes as well. What were the broad classes for inline fixes? I mean, it was everything, right? Like, no, for just for like inline type fixes. Like, there's a lot of BiDi fixes.
Yeah,
that was the biggest thing. Yeah, we had some very happy users on Twitter going, "Hooray, my Arabic." Use cases finally fixed and stuff like that. So gone to performance. So we improved paint throughput a little bit. The top one is Android with LayoutNG off versus on. This is primarily due to text layout again. We've got the shape results already pre-cached. We think we'll also potentially get additional paint improvements over time. The bottom, so it also differs quite a lot based on region. So the bottom is just looking at Japan. And so that has a bigger performance win. Is the next one the scary one that I need to explain? Yes. This is the layout. This looks much scarier than it actually is. So let me explain. Everything here is under 1 millisecond. So basically, the way to think about this is that every user experiences a 99th percentile layout at least once on their page load. And basically, we think we need to investigate why we slowed down these like tiny layouts. I think we know why, but we're going to try and fix that and investigate it. But the thing to concentrate on here is that the really long layouts, or just like even just a standard layout where you're changing a lot of DOM, they are super fast now. So we really need to like, we sort of need a different metric here that basically takes the longest layout that we've seen and then analyzes that. That would be far more interesting. Just because like this is just tiny little layouts that actually really don't matter that much. What this resulted in was actually a pretty big win in LCP for one relatively small component. We only saw this improvement to this extent for complex script countries. So I think the top one, I think that's Thailand from memory, from 1 hour ago when I was plotting this. So we saw an improvement of, call it 1.5%, maybe reaching 2% in Thailand. The bottom is an aggregate of a whole bunch of Arabic countries, Arabic script countries. So like Pakistan is pretty interesting at the moment. Population of about 200 million people. Internet penetration, the graph for that country is just astronomical at the moment. This includes Saudi Arabia, Egypt, yeah, so a whole bunch of complex script countries. They get a really, pretty sizable dent in LCP. The blue background is that this is actually, it's basically statistically significant. So you can more or less trust the ones in blue. The ones that aren't in blue, you can trust less. It's difficult. This was running a 1% experiment. So it's difficult when you drill down into specific countries to actually get enough signal. So, like at the top level, like Latin just dominates. But when you look at the complex script countries, so this is, a lot of them aggregated together. And then Thailand was just a very clear win. There was a few other countries that were clear wins. So Pakistan was a clear win as well. But that was pretty awesome to see. So sort of the current state at the moment. Any questions on metrics? Yeah.
Do you have a target performance when you started out?
We knew that there was opportunity for it, but I personally didn't know how much it would actually move. It was very difficult to have an understanding of how much would move it. We didn't know, we knew how much, we knew that layouts do contribute a lot of time up until the point where you have a LCP. You just open up any website, you can see, there is a giant, humongous layout there that's taking, 400 milliseconds on an Android class device or something like that. We knew that we're spending a lot of time in inline layout, which is typically, a large component of it. I don't know, Herji, did you have a good understanding of how much? It was still very difficult to.
Yeah, I don't think we have numbers, but we have some cases where 10 layouts takes minutes. And those are how to fix in the order architecture.
Yeah.
So in design, we want to make sure that those edge cases are really covered.
Mm-hmm.
Make sure everything is time frame while making common cases 5-10%.
Yeah. The other thing is when you drill down into some sites got a lot quicker as well. So we think that we moved YouTube substantially. These numbers are all aggregate. So you're taking the whole internet for these countries. If you drill down into individual sites, typically got a lot faster. Some sites were just flat because they're not that text heavy, or they're already doing, they were relying on our existing caching logic. Well, we think that the big improvements were primarily due to they were hitting some case which we couldn't cache previously, or they had a lot of text which we previously couldn't do well. And this is sort of why you see the LCP improvement in the complex script countries is because every website is benefiting from that, whereas in the Latin countries only a few websites were benefiting from the performance characteristics. Does that make sense? Great. Anything else? Okay. So where are we currently at? We tackled the big hairy beast, which is all of flow layout, except currently we'll fall back to the current engine for fragmentation, editing, and Ruby. So whenever we've got content editable, we'll kick back to the old engine. If we see something Ruby-like, we can't support it quite yet. And if we're printing, we basically rebuild the whole tree and print it. The fragmentation on the old engine is pretty busted and broken, and we wanted to make sure that we did fragmentation right. This is sort of our next steps here. So we're converting inlines into a flat list. This should improve our memory and inline performance again. There was a sort of architectural, we went down a slightly wrong architectural path with our inlines initially. It also means that when we get to editing, that should be relatively trivial. I'm looking at Koji and he's nodding. So Koji is quietly confident, which is good. I should say, like, all the other big layout types are, now that we've sort of done this large work of reverse hosting and everything like that, switching things over is relatively easy. So LayoutNG is almost done. That's just basically converting Flexbox over to the new code base. We did quite a lot of fragmentation work pre-launch to make sure that we got all the fragmentation primitives correct. So Morton's currently working on that, and that will be, we'll probably, anything that's got only flow layout in it and multicol, that's sort of our first sort of mini launch with fragmentation. But that's sort of the tricky one to get right. The other thing that we're working on is that tables have got about 150 open bugs against Blink at the moment. It's a real source of developer pain. People want to be able to, sticky pos their, some table row, for example, or rel pos something. There's a lot of really nasty bugs related to this. So we basically, with that implementation, want to be able to, fix another, 100, if we get lucky, 150 bugs, which will be awesome. And that'll provide a lot of value to web developers. There's a lot of performance work now that we want to investigate as well. So we have a relatively large pre-layout inline step where we do segmentation, BiDi, initial shaping as well. And we spend approximately 30 to 40% of all layout time in this pre-layout step. And we think that we can potentially parallelize this and move this off thread. So that, if we can do that, that will be a relatively large win for basically every web page. So those long layouts, we basically potentially can cut down the main thread time, maybe by 20–25% of layout. So that would be pretty cool if we can get that working. But that's difficult. We'll see how we go. We think that we can do some additional intrinsic sizing operations. We know that we spend a lot of time in a scrollable overflow calculation. We're currently relying on the old system for that. That currently spends 5% of all layout time in that calculation. We think that we can reduce that to something relatively trivial. And LayoutNG, we want to be able to enable a whole bunch of additional layout primitives, which were previously impossible or extremely difficult with the old architecture. So this sort of ties back to the start of the talk with, it should be relatively trivial once we've got all the fragmentation working to add something regions-like to the engine. We should be able to do variable page printing pretty trivially as well. So basically, we looked at what was in the future, and we wanted to make sure that we would enable pretty trivially all these use cases. Questions? Nope. Sweet. That's it. And now another questions. And I roughly came in on time. Wow. That's awesome. Nothing? I've answered all your questions. Yes.
How long until you can take the NG off of all of these new types and make this the layout?
The layout. So I think, oh yeah, I can repeat the question. So basically, how long until we can drop the NG prefix and make all these types just normal layout?
For some of them, you removed it from some of the join class classes.
Yeah, so we actually pulled in, so having all of these, where did it go? Having all of these types turns out to be useful in the rest of the code base. And so we actually pulled out the offsets and physical sides, and there's a few that isn't there, and the rectangles, and that's starting to percolate through Paint. When we can call sort of like LayoutNG like mostly done, I think probably around the end of next year, we'll be able to start ripping out code. Yeah, so I think with our current, like basically the first bit was sort of like the most, like the amount in flow layout is just crazy. And so I'm sort of glad that was almost naive at that point in time. Converting things over, doing fragmentation correctly, it's work, but like we know how to get there. And we've also got, Microsoft folks, starting to look at this area as well, which should be really exciting.
So there will be a party when we're done.
Yes, absolutely. I think, yeah, I drank some wine with ML when he was leaving, when we're sort of done the big first bit. But this sort of phase that we're sort of coming out of now was like, that was the huge mountain. Everything else is a lot smaller in magnitude and can sort of be done in parallel. Whereas this was, we need to solve lots and lots of problems like, okay, how do we copy back all the information to the old data structures? How do we make sure that we can go from an NG world into a legacy world safely and vice versa? There are a lot of problems that we needed to solve, which is why, the graph sort of looks like this, in that, there's some, steep things of like, we fixed the class of crashes, or we managed to enable reverse hosting. But now that we've got all of that infrastructure, it's much simpler. Sort of when we add like support for like Flexbox and NG, we want to make sure that fragmentation works correctly there. So we'll add that on, and that'll fix another class of bugs. So it is, I'm excited.
So next year.
Yeah, end of next year, I think we...
2 more BlinkOns, 3 more BlinkOns.
2 or 3 more BlinkOns, I think we'll be able to start ripping out large parts of code. And we'll be able to do larger like architectural changes at that point as well. It's difficult at the moment because like everything talks to the layout tree. Like this is, this data structure tree has been around in some form or another for 20 years. And so everything talks to it, which is awesome. There's some very interesting stuff that happens there. But we think that like we'll be able to do larger architectural changes at that point. Like one thing that we're considering is that, or like, toying with it at least, is that we can potentially move Paint, like the Paint phase, off to a separate thread. And that means, instead of, that, 5% improvement that we showed there or whatever, that turns into 100% improvement for the main thread. So there's, some bigger architectural things that we'll be able to, unlock at that point. The reason that we can potentially move it off thread is that we've got an immutable tree that we don't have to lock and do all sorts of malarkey to get happening. So like architecturally, we're going in the right direction, but, we're sort of almost paying down a 20-year technical debt credit card at the moment. Again, that was me. That was good therapy for myself. That was great. Yeah, anything else? Sweet. All right. Thank you very much.